Hi all, welcome to Kothite channel. Let's take a look at the handwritten digit recognition model which we are going to build from scratch in this video. Let's take a look at the demo first, how it is going to looks like. Here is the final demo. So hand digit recognition model. So here we have a text box and here is the image. Okay, here it is going to, the model is going to predict the what is the digit in that particular image. Okay, we have the images from 0 to 1, 0, 1, 2, 3, 4, 5, right? I have just created them. Okay, let me zoom in a little bit. Okay, so here if you see here, images are there. Okay, 0, 1, 2, 3, similarly to 4, 5, 6, 7, 8, 9, 8. All these images are there over here. Okay, 4, 5. Okay, so I'm going to predict. Okay, if I change this image name to 1, then it is going to predict the values and it will display the image as well. Okay, first it is 0.png, so it is 0. Okay, it is predicting correctly. Now let's change it to 2. Okay, here it is predicting properly, image as 2. Now let's change it to 3. Here it is predicting 3 correctly. Okay, now let's change it to 4. Yeah, here it is predicting correctly. Now to 5, it is predicting it as 2. It's wrong. Okay, let's change it to 6. Yeah, it's predicting properly 6. And 7. Oh, it is predicting it as 6. Okay, now let's change it to 8. It is predicting it as 3. Now finally 9. Yeah, it is predicting properly. I think out of 10 images, I think 2 to 3 images are gone wrong, right? I think 70 to 80% of our model is working fine. Okay, so here is the final demo, how it looks like. So this is how you guys can create the hand digit recognition model by using the TensorFlow MNIST dataset. Let's dive into the coding. One of the followers has asked me to do the Google Colab demo. Okay, this machine learning model I'm going to develop by using the Google Colab and I will be deploying it as a web application. I'll show end to end. Okay, first let's open the Google Colab. Just type in Google Colab in the Google search bar and then you will just open this link, Google Colab. Okay, so if you click on this link, so this window will come. Just click on new notebook. What is Google Colab? So Google Colab is short form for the collaboratory. It is like a laboratory which will be provided by the Google and it is free to use. And why we need to use this Google Collaborator? The main reason is it is coming up with the free resources here. If you see here, if I click on here and then if I click on view resources, if you see here, it is giving us the 12.7 GB of system RAM and 107.7 GB of disk space. So why do we need this much of RAM and disk is? So if you are familiar with the machine learning developments, so machine learning models always requires the large amount of data. So to process the large amount of data to get trained that machine learning model, we need the large amount of the resources as well. So Google is providing this platform as a free of service to each and every user to support the machine learning development. Okay, the main reason I would recommend you to use the Google Colab is because of these resources. So these resources make us our programming very sharp and the execution is also very fast. Okay, and second reason is it is a web-based application. So whatever the changes that you have been made for this notebook will be stored forever and you can save this Python notebooks in the your Google Drive as well. Okay, and here are the list of the options. So here you can rename this one. So here we are building the handwritten digit recognition model, right? So that is the model, so that's the name. And here you can save this as a Python notebook .py, or if you want to be a Jupyter notebook, you can keep it as a IPYNB. Okay, and here you can load from the your Google Drive or you can save this into the Google Drive and you can save as a copy in GitHub as well. You can link your Google Drive and GitHub both to the Google Colab and you can open your notebook, open, upload and renaming, all these things are there and you can download your code as well. And here is the basic options and if you have the runtime options, you can choose these runtime options over here. So the main reason I would recommend Google Colab is because of its resources and these resources make us the machine learning models to run very sharp and they get trained with the large amount of data set. That is the main reason. And second thing is it is a web-based application, right? So you can code from anywhere, from your laptop or from your mobile also you can build the machine learning models. Okay. And third thing is, in this web application, what I'm going to do is I'm going to build the complete web application by using the Google Colab. Okay, how I'm going to build the model and how I'm going to deploy that machine learning model as a web application with the Google Colab. So earlier I have made the videos with the help of the local and with the Streamlit. So how I'm going to use the Streamlit with a little bit of difference. Okay, just please stay tuned for the end of the video so to get to know more about this. Okay, so let's get started with the coding. Okay. Text, first one is, here you can add the text and code just by clicking on these links. Okay, I'm just deleting this text, we don't need. Okay, let's start with the coding. So first things first, so first we need the Python libraries, right? So to install the Python libraries in your Google Colab, so you have to follow this command, pip install and the library names. Let me increase the font here. Okay, pip install Python library names, NumPy, Pandas, and here we need the TensorFlow as well, right? TensorFlow for the MNIST data. So why we are going with the TensorFlow is TensorFlow is having the models. That is the first thing. And second thing is the handwritten digit recognition data set is, right? That MNIST data set is also there in the TensorFlow. So that is the reason we are going with the TensorFlow here. And we need the NumPy and Pandas basic things. And we need the Matplotlib. This is to draw the charts and graphs. And so we have NumPy, Pandas, TensorFlow, spelling mistake here, TensorFlow and Matplotlib, and CV2 to read the images from our local. Okay, so these are the libraries that we will need. So to install this Python libraries in the Google Colab, you just have to type this exclamation mark and then pip install. So when I press shift and enter, these libraries will be getting installed in your session. Okay, all these libraries are already installed in my system, so I'm not going to install them separately. Okay, just remove them. So now let's start with the coding. Okay, import NumPy as np. So first things first, libraries, import matplotlib dot pyplot as plt, and next is TensorFlow as tf. Okay, just plus enter, shift plus enter, so it will be executed. So it is executing here. Okay, and next thing is, let's import the data set from the TensorFlow. So what is the data set we need? We need the handwritten digit recognition images so that we can get our model get trained on that. Okay, so this data set is called MNIST data set. Okay, tf dot. So for the suggestions in Google Colab, similar to Visual Studio, just press Ctrl plus space bar. Okay, tf dot keras dot datasets dot MNIST. Okay, and we have to shift plus enter. Okay, it's running fine. Now next thing is we have to load it into the training data set and test data set, right? So x underscore train, y underscore train, and x underscore test and y underscore test. So the advantage of this data set is it is already split into the test data, training data set and test data set. Okay, I'm just splitting that into the training data set and test data set. Okay, MNIST dot load data set, load data. Just shift plus enter. So it is downloading the data. So data has been downloaded now. Okay, now let's see the how many training images are there and how many images are there in the test data set. Okay, let me print x underscore train dot shape comma y underscore train dot shape comma x underscore test dot shape comma y underscore train, sorry, y underscore test dot shape. Okay, shift plus enter. So if you see here, it is having the training data set is having 60,000 images, and the next one is 2828. This 2828 is the width and height of the pixels of the image. Okay, and 60,000 images are belongs to the training data set, and 10,000 images are belonging to the validation data set. That is the test data set. And here this 60,000 is the output, and 10,000 here is output data set. Okay, now we have the, let's print some images from the training data set. Okay, by using the pyplot. Plot dot figure of fixed size is equals to 8, 8, and plot dot, sorry, for I in range of, let's print 9 images. Okay, and plot dot subplot of 3 comma 3 comma I plus 1. Okay, I just wanted them side by, and plot dot image show of, and what we are showing here is x underscore train of I. Okay, that's the image here. And plot dot, let's print the output dataset as well as the title. Okay, that is there in the y train, y underscore train of I. Okay, and plot dot, let's stop the axis. Okay, press enter. Okay, let me resize to reset. Okay, this is here. Okay, if you see here that this is the handwritten digit of 5, here it is 0 4 1 9 2 1 3 1. Okay, so this is how the images will be there. So we have the 60,000 images as a training data set similar to this, and each image is 28 pixels of width and 28 pixels of the height. Okay, and here it is the test data set is having 10,000 data sets, 10,000 records. Okay, now we have the data set. Okay, and let's do one more thing. Let's normalize this data set. Okay, this is the coming from the arrays, right? So let's do the normalization of this data set. Okay, x underscore train is equals to, so we have a function, built-in functionality in TensorFlow to do the normalization. Keras dot details dot, okay, normalize. Okay, now what we are doing, train x train, and axis is equals to 0. Okay, similar way for the test data set as well. X test is equals to tf dot keras dot utilities dot normalize. Okay, and we need test data set x underscore text comma axis is equals to 0. Okay, just shift plus enter, and data has been normalized. tf dot keras dot spelling here utils. Okay, it's completed now. Now our data set is normalized. Now what I'm going to do is, here I'm going to add the text of let's delete this one. Now we have the input data set. Okay, now what I'm going to do is, I'm going to build the model. Okay, now let's come to the code. I'm just building the model. So this is how you can add the text as well. Okay, you can make it as a bold and italic as well. Okay, building model. So what is the model that we are going to build is, so we are going to build the sequential model here. Okay, so model is equals to tf dot keras dot models dot sequential. Okay, once our model is ready, then we have to add the layers. So what we have to do is, whenever we are building the keras model, so we have to go with the layers. So first thing which I'm going to add is model dot add of, and what I'm going to add here is tf dot keras dot layers dot flatten. Okay, and input size is equals to, put shape is equals to 28 comma 28, right? So that is what. So what exactly this flatten does is, so it will build, instead of we are having this array of 28 into 28, right? 28 comma 28. So instead of that, it will build a one single one dimensional array 28 into 28. Okay, it will be around 784. one single array. It will be the number of the numpy array will be a single row. So in simple terms, it will be instead of two-dimensional array, it will make it as a one-dimensional array. Okay. And next, model dot add tf dot keras dot layers dot dense layer. I'll add what I'm going to add is 128 nodes, and activation is equals to relu. Okay, I'm just going to add these layers like dense layers only. One is 128 and another one 64, and finally one with the 32. And finally add tf dot keras dot layers dot again dense layer with that 10. Okay, that is the outcome, right? 0 to 9, so total 10 digits, right? And here activation is equals to softmax, because it is an output, right? So that's the reason it will be a softmax activation. Yes, pressing shift plus enter. Yeah, model has been created. We can just check it out with model summary. Yeah, so here is our model. So first thing is, first layer is we are flattening the data set. If you see here, it is being 784, the shape has become. Okay, and one of the dense layer with the 128 nodes, and one with the 64, and one with the 32, and finally here is the 10, that is the output data set, right? So that's the reason we have the 10 data sets here. Okay, closing this one. Now do the compiling of our model dot compile of, and here we have to do optimizer Adam, and loss is equals to tf dot keras dot losses, right? So sparse categorical class entropy will be adding it, and here from logits is equals to true for this one. And once it is done, we need the metrics, right? So metrics is equals to accuracy. Okay, so compiling of our model is completed. So we have created the model, and we have added the compilation of our model. Now let's fit our model. Let's train our model. Okay, model dot fit. So what we need, training data set, right? X underscore train. Okay, X underscore train and Y underscore train. So we are going to fit our model with the input data set, training data set, and we need the validation data set as well, right? So validation data is equals to X underscore test, Y underscore test, and I'm going to add the batch size here. Batch size 32, and here epoch is equals to, let's have 15. Okay, let me press shift plus enter. Okay, so our model started building it. Now our model has started fitting it. If you see here, when I was building this machine learning models from my local system, it was taking a lot of time. So but now here it is taking just 12 seconds. I think I remember in my previous videos when I am recording it, it was taking around 60 seconds, close to 60 to 70 seconds for one epoch, but here it is very fast. If you see here, it is completed in the less than 10 seconds, 10-12 seconds. So that is the advantage of using the Google Colab. So it will be very fast and quick. And while it is building, so here we have some sections. So here we can add the sections as well in the Google Colab, and here we can find and replace these ones, and here we can filter the variables. And if you want to add any secret keys like API keys or anything, right? So you can, instead of having that API key, you can create a secret key, and then you can use that name over here in the coding as well. And here it is the files, whatever the files that you want to add, input files or output files, you can save the models in these folders. So this is what the advantage of these things. Okay, this ribbon. And let's complete how many it is completed. So 8 completed already out of 15. Okay, So let's take a look at the code one more time. Okay, what we have built so far. So here we have imported the the basic libraries which is required for us. One is the NumPy and Matplotlib PyPlot for the printing the images from the dataset, and here we have used the TensorFlow. Okay, and here we have taken the MNIST dataset, we have created an object, and from that we have loaded the data. So the advantage of the TensorFlow is it is already splitting the data of training dataset versus test dataset. Okay, and here training dataset is having the 60,000 images, and test dataset is having only 10,000 images, and each image is 28 by 28 pixels. Okay, here we have printed some basic images from the training data set. Okay, and here we have normalized the our training data set and test data sets, and here we have built the sequential model, and sequential model we have first layer is added as a flatten. Okay, so instead of 28 by 28 we are flattening this into one single one dimensional array, and here we have added three dense layers, one with the 128 and one with the 64 and one with the 32 nodes, and finally the last one is the denser layer with the 10, because we need the 10 outputs, right, 0 to 10, and that's the reason activation is equals to softmax here. Okay, and here we printed the model of the or summary of the model, and once that is completed, and we have compiled with the optimizer is equals to Adam, and the loss is equals to sparse categorical cause entropy, and matrix is equals to accuracy here. Okay, and if you see here, the accuracy started with the validation accuracy started with the 86, and it has been reached to the 96 percentage. Okay, it is really cool. See here, so 60,000 images data set has been completed, I think less than 2 minutes, I guess 15, right? I think on average it is taking the 1.5 minute, I think it took time to complete this fitting of this model with the 60,000 images, and it has been validated the dataset against the 10,000 images. So that's the reason we will prefer the Google Colab over the local missions. Now we have built our model, right? So what I'm going to do is have some couple of images which I've shown in the demo, right? So let me add those images here. I'm just going back here. So here we have the list of the things. Content is the first one where we have to upload our files and everything. And just remember one thing, whenever you're using Google Colab, right? So whenever you're uploading your files into these folders, right? So this will be available only for the next 12 hours. So if you are not using that, and your session will automatically closed, and once your session is closed in the Google Colab, so whatever the files that you have uploaded or whatever the files you have saved with the code, those will be gone. So if you want to be save these files, you have to save these files especially in the Google Drive, or you download it on your local system. Okay, and if you want to save it for more than 12 hours, then you have to go for the Pro. Google Colab Pro option is there, so you have to buy it with by paying some amount. And here I'm just taking the images from 0 to 9. Okay, so I just added these images. See here it is giving a warning, ensure that your files are saved elsewhere. This runtime files will be deleted once the runtime is terminated. Okay, just remember that. And yeah, so our images are there, so let's predict. So I'm using CV2. Okay, for the reading our images. Okay, and image is equals to CV2 dot image read. Yeah, I am read. And what is it? Let me print 0 dot png, and here we have to give the all these images are 28 pixels. Okay, width and height. So if you want to create these images, just open Paint, and here you can set the size as 28 pixels. Go to pixels, 28 pixels horizontal and 28 pixels vertical. Then you can zoom in. Then you can write the with the help of this pencil, you can write these images. So this is how I have saved all these images with the 28 pixels and 28 pixels here from 0 to 9 for this example to showcase for you guys as a demo. Okay, so that's the reason I'm not passing any image size, because all are 28 pixels, right? And then this is a 0. So once it is done, and image is equals to np dot invert of np dot array of, okay, image. Okay, it's completed. Now we have to pass it to our model, right? Let's pass this input message input image to the our model dot predict of image. Okay, and plot dot image show of image, okay, 0, and let's print the value, right? Print np dot argmax, so that is the maximum value, right, from the output. Okay, let's predict it. The image is 0. If you see here, the value it is predicting it as 0. Okay, let me change it to 1.png. 1.png. Okay. Okay, model is predicting. So if you see here, it is treating it as 3, okay, instead of 1. Okay, that is somewhat bad. So model is not predicting properly. And let's check for 2. So here it is predicting it as 2. Okay, similar thing for 3. Here it is predicting it as 3. Okay, so fine. I think out of 3 images, right, out of 4 images, 0, 1, 2, 3, out of 4 images only 1 image was wrong. Okay, that's fine, and our model is working fine. Now we have to save our model, right? So let's save our model. Okay, model dot save in the content folder slash and written digit recognition model dot keras. Okay, let's save this model and let me refresh here. Yeah, if you see here, our model has been created here. So now the next challenge is how we are going to deploy it as a web application, right? So we have our model and our model has been saved now. So now the next challenge part is how I'm going to deploy it as a web application. So what are the Python libraries which we would require to deploy our machine learning model as a web application by using the Google Colab. Okay, the first thing we need is Streamlit. Anyways, that is similar to what we do in a local system, right? So we have to install pip install Streamlit. Okay, so after installing that Streamlit, the next thing we have to use that as another application is npm install local tunnel. Okay, what exactly this local tunnel does is, so it will give a platform to run our applications as a web applications. Okay, so you can install with the, instead of pip we have to use the npm install local tunnel. Then you guys can install this npm as well. Okay, I have already installed this in my session. So if you are using for the first time, you have to use the pip install Streamlit first for web to deploy it as a web application. Second thing is we have to give the local tunnel with the npm. Okay, so once you guys have installed both of these two things, so once you guys have installed these two things, the next part is create a application, right? So now I'm going to the content, new file, app.py. Okay, and let me open that file, and I'm just here. This is what we are going to do. So here I'm going to write the code to deploy Streamlit code here. Okay, to deploy it as a web application. It is now different. Okay, so till this step also, including this step. So first step, creating a model and saving that model, usual similar to our local thing. And second thing also, we are doing the app.py. I'll just, there's only differences when we are running it. Okay, I'll show you that one as well. Okay, import Streamlit as st. Okay, it is giving this warning, so that means it is not being installed in this environment. Let me install it. Okay, pip install Streamlit. It's downloading. Yeah, it's getting installed now. See, once it is being installed, this warning has been gone here. Okay, just going here and I'm just closing this one. Okay, now import Streamlit as st. And what else we need? Import numpy as np. And what else we need? Import TensorFlow stf and import cv2 for the images. Okay, and st dot header of what I'm going to do is hand digit recognition model. Okay. So once we have set it, what I'm going to do is st dot text underscore input. We need the image name, right? So here enter image name. Okay, and I'm going to save it as image. Okay, so once we have the image, we have to pass it to the model. So let's import the model. Okay, model tf dot keras dot models dot load model. Okay, and here you can copy the path like this as well. Copy path, just going to use it as it is. Okay, and so we have the model. Let me put this statement first. Okay, st.header and digit recognition model. Next we have the text input. Now once we have the image, we have to pass it to the our model. So before passing it to the model, we have to convert it into the way how our model is going to expect this image, right? So for that one, we need the cv2 image, right? Image is equals to cv2 dot. I think we have already have this code, so I don't want to write it again. Let me copy paste it here. Okay, instead of this one, what I'm going to do is img. Okay, so we have the image. Next, what else we need? We have to pass it to the model. Okay, output is equals to model dot predict of image. And okay, and here I will like to add a one string digit in the images plus np dot argmax of output. Okay, and st dot markdown, we have to print that, right? Markdown of stl. Okay, let me save this one. So Streamlit, NumPy, TensorFlow, we have imported our model, and this is the header for that web application. And here we are taking the image name as an input, and we are converting that image to before passing it to the model, and then we are passing it to the model, and we are predicting that value in the image, and here output. Okay, let me save it. st.markdown as the string. Okay, we have the app. Now let's run it. Okay. Streamlit run content slash app.py, and I'm going to, if I run it, what exactly happens is slash content slash logs.txt. Okay, press enter. So if you see here, let me refresh here. If you see here, it has created one file called logs.txt. Okay, this logs.txt is giving the network URL and this external URL as well. Okay, now what I'm going to do is I have to write one more command. Okay, npx local tunnel port as 8501. Okay, let me run it. See here, it is going to give a path here, right? Just click on this path over here. Okay, so it will open this tunnel website ahead. So here it is giving an endpoint. Okay, what exactly have to do is the step one, when we have executed this Streamlit run, right? So usually when we are running it even local as well, it will give this network URL, right, and external URL. And but when we are setting this local tunnel as 8501, right? So what I'm going to do is I have to copy this whatever the data which is there in this external, right? So what I have to do is they have to copy this public address. Okay, 35.223.209.34. I have to copy it and I have to paste it here. Okay, and I have to press click to submit. Now our Streamlit website, whatever the web application that we have built, it is running now. See, Okay, because it is not having any images, right? So that's the reason it is giving this message 0.png. Okay, I have to convert it to the str, right? Where is app.py? Let me close this one, and we don't need that. And app.py, str convert to string first. Okay, converted, and we have saved it. So source file has been changed. Yes, always rerun. See, digit in the image is 0. Okay, let's print this image first. Okay, and for that one we have to add one more step, right? st dot image of img. Okay, saving it. It's running 0. Okay, let me increase this size. Width is equals to 300. Okay, see, here is the image and here is the uh, prediction it is predicting. Okay, now let's change it to 1. Here it is saying it as 3 dot. Okay, fine, and let's change it to 2. Yeah, it is saying it is image is 2. Here is the final demo. So hand digit recognition model. So here we have a text box and here is the image. Okay, here it is going to, the model is going to predict the what is the digit in that particular image. Okay, we have the images from 0 to 1, 0, 1, 2, 3, 4, 5, right? I have just created them. Okay, let me zoom in a little bit. Okay, so here if you see here, images are there. Okay, 0, 1, 2, 3, similarly to 4, 5, 6, 7, 8, 9, 8. All these images are there over here. Okay, 4, 5. Okay, so I'm going to predict. Okay, if I change this image name to 1, then it is going to predict the values and it will display the image as well. Okay, first it is 0.png, so it is 0. Okay, it is predicting correctly. Now let's change it to 2. Okay, here it is predicting properly, image as 2. Now let's change it to 3. Here it is predicting 3 correctly. Okay, now let's change it to 4. Yeah, here it is predicting correctly. Now to 5, it is predicting it as 2. It's wrong. Okay, let's change it to 6. Yeah, it's predicting properly 6. And 7, oh, it is predicting it as 6. Okay, now let's change it to 8. It is predicting it as 3. Now finally 9. Yeah, it is predicting properly. I think out of 10 images, I think 2 to 3 images are gone wrong, right? I think 70 to 80% of our model is working fine. Okay, so here is the final demo, how it looks like. So this is how you guys can create the hand digit recognition model by using the TensorFlow MNIST dataset. If you like the content in this video, please do like and subscribe to our channel. Thanks for watching this video.